Good morning, everyone. We were discussing about what are biopesticides, and we were also discussing about different categories of biopesticides. In today's session, we will try to understand about biopesticide formulations, the mechanism of action, advantages, and disadvantages. Later, we will also try to understand about the process of bioleaching. So essentially the active ingredients of biopesticides, they are formulated in the same way as the synthetic pesticides are formulated. And the formulations are convenient for the use by the farmers with the same equipment which they were or they are using for applying the synthetic pesticides. So the formulations or the biopesticide formulations should match the design of the existing equipment used for the synthetic pesticides. So the formulations are made in such a way that it meets the requirement of, or it becomes a convenient for farmers to use the same equipment for applying the biopesticides as the farmers were doing for the synthetic pesticides. So the basis for most of the biopesticides is living organisms, and their viability have to be maintained during the formulation process. Biopesticides is essentially about the utility of living organisms, and when we are using living organisms, their viability have to be maintained throughout the process. That means here we are discussing about formulations. So the viability of microorganisms or the living organisms that is being used has to be maintained during the formulation process and stored at acceptable levels. So the organisms must revive from their dormant state after storage. So the organism's revival is also equally important from their dormant state in order to be active at the time of application of the pesticide. So as soon as you manufacture the biopesticide, it doesn't find application. So it has to be stored, and when it is in storage condition, the viability of the living organisms have to be maintained, so that once you revive, the organism has to come to the active state at the time of application of the biopesticide. So these are some of the important principles of formulation of any biopesticide, right? So the final product is maintained by mixing the microbial component, that is living organism, with different carriers and adjuvants. So you have a combination of living organism with various or different carrier molecules and adjuvants. So all these are mixed during the formulation process. For the reason number one, better protection from environmental factors, because the living organisms cannot be used alone. Acclimatization is a problem. We have discussed in the previous session quite a lot about it. So better protection from environmental factors. So the formulation requires several other molecules such as carriers and adjuvants during the formulation process. And controlled rates. Number 3, improved bioactivity. And number 4, better storage stability. So all these are important factors that govern a good biopesticide formulation. Number 1, better protection from environmental factors. Number two, controlled rates of release of the biopesticide. Number three, improved bioactivity with respect to the organism. And number four, better storage stability. So, to achieve the most important function of any developed biopesticide formulations, there are several factors which contribute to that. Number one, easy handling and application of the product. So, whatever the biopesticide formulation you do, it should meet the following requirements. Number one, easy handling and application of the product. Number two, stabilization of the microbial agent during distribution and storage. So manufacture happens at site A and it has to be distributed to several sites, and there should be storage facilities, and the living organism should be stable during distribution and storage conditions. Number three, protection of the bioagent from adverse environmental conditions, right? Because it is an open field and unpredictable with respect to weather conditions. So the bioagent or the living organisms which are formulated as biopesticides along with carriers and adjuvants. So the protection of these bioagents from adverse environmental conditions is very critical. So it's an important factor to achieve the most important function of the developed or any developed biopesticide formulations. And number four, enhancement of the bioagent's activity. That is what we are trying to understand by increasing contact and interaction with the target pest. That is most important and necessary to be ensured. So these are the four important factors. In brief, better protection from environmental factors, controlled rate, number three, improved bioactivity, and number four, storage stability. Right? Now, how the biopesticides are formulated? Biopesticides are formulated in various ways. In general, biopesticides are usually formulated as number one, dry formulations, that is specific for direct applications, and number two, liquid formulations, right? So generally biopesticides, they are formulated as number one, dry formulation and liquid formulations. Dry formulation for the purpose of direct applications, right? So depending on the physical state of the biopesticide formulation as dry or liquid forms, the active ingredients are produced by addition of number one, stabilizers, number two, synergist molecules, number three, spreading agents, number four, sticking agents, number five, surfactants, number six, coloring agents, number seven, anti-freezing compounds, number eight, any additional nutrients, number nine, dispersants, number 10, melting agents. See how many molecules or compounds or agents are added during the formulation process to make the biopesticide formulation very much easy to handle, stabilization of the bioagent, protection of the bioagent, and enhancement of the bioagent activity. Right. So essentially the biopesticides are formulated as dry formulation for direct application and liquid formulations. So depending upon the physical state of the biopesticide formulation as dry or liquid forms, the active ingredients are produced by adding or addition of stabilizers, synergist molecules, spreading agents, sticking agents, surfactants, coloring agents, antifreeze molecules, additional nutrients if required for the bioagent, dispersants, and melting agents. So all these are added so that the biopesticide formulated meet the requirements as discussed in the previous slide. Right. Now, here this table gives you an idea about some of the biopesticide formulations that are available in commercial quantity. Just I'll name some one or two. You have the product name, the Antagon, and the agent used is Trichoderma viridae, and the target site is the Solani, Rhizoctania solani, and Macrophomina phaseolina, and then we have the Biocon, that is Trichoderma viridae. This is for root and stem disease of tea, and then we have Biotope, that is Bacillus subtilis. This is for Corticium invisum. So there are several biopesticide formulations that are commercially or that are available in commercial quantities. This is just a list to make you understand different product names or the commercial names and the active ingredient or the bioagent that is being used against specific targets, right? And some of the successful experimental use of biopesticide against various diseases are, say for example, we have Trichoderma viridae against Fusarium oxyforum, that is the host or the crop is pigeon pea, and then I'll mention something like we have Bacillus subtilis, that is Ralstonia against tomato, and then we have Arzianum. So there are several pathogens for Arzianum and several host plants for that. Most of them are having the bioagent, the Trichoderma viridae. So these are some of the successful experiments. You can find a lot of information on this in several research articles. Just I have listed very few. So if you just look at the crop plants, you can see rice, chili, tobacco, tomato, maize, black pepper, so peaches, so sunflower is there. So you can make out the application or use of biopesticides that is in a very broader way, right? So moving further, we have two formulations, as I said earlier. Number one, dry formulations specifically for direct applications, and liquid formulations. So under dry formulations, we have number one, dustable powders, so that you have the powder and you can dust it. So it is like spraying. And second, we have in the form of granules, and then we have seed dressing. So it is about coating the seeds, and then we have vegetable powders. Number five, water dispersible granules. So I'll not go into the details of each one of the type of the formulations coming under dry formulation or liquid formulations. That is out of the scope for the present understanding. If you really require to know better, we will have you have to access several research articles which are available in PubMed. So under dry formulations, for easy understanding, there are five different types. Number one, dustable powders. Number two, granules. Number three, seed dressing. Number four, vegetable powders. Number five, water dispersible granules. And under liquid formulations, we have emulsions. Number two, suspension concentrate. Number three, suspo emulsion. Number four, oil dispersion. Number five, capsule suspension. Number six, ultra low volume liquids. So under liquid formulations, we have more types when compared to direct formulations. So these are the important types of the formulations falling under dry formulation and as well as liquid formulations, right? So the method or the efficient technology or the application of the technology. So the effective control of pest. So biopesticide is essentially against the pest. It can be achieved by good selection of an appropriate application technique or method and an appropriate time and or frequency of the application of biopesticide. So a better selection of the technique, number one. Number two, an appropriate time of application. And number three, frequency of application of the biopesticide. So that makes an effective biopesticide controlling agent against the intended or target pest. Right. So there should be good selection of the technique or the method to apply, and number two, an appropriate time to apply the biopesticide, and number three, frequency of application of the biopesticide, which governs the effective control of pests. So if you don't follow these three steps, then probably the effective control of biopesticide may not be significant. So it doesn't mean that the biopesticide is not working or not efficient or not good enough to control the pest. There could be lacunas in following these three important steps. That is, good selection of the application technique so that you use minimum quantity of the biopesticide and you do not waste the biopesticide, and number two, appropriate time. So that depends upon the target, the crop, when usually the crop is getting infected, what are the what at what stages of the development of the crop the infection starts. So appropriate time of application of the biopesticide and the frequency, how often is it, one time, two time, or three times the application is required. So thorough understanding of the crop development, growth and development, and the infection mode is also equally important. It is not only just spraying or spreading the biopesticide or dusting the biopesticides. So these three are important steps that makes a biopesticide effective against controlling the pest. Right. Now, some of the methods of biopesticide applications are to understand in little details. Number one, seed treatment. Right. So one way to apply biopesticide is by seed treatment, and it is the most effective method or the technique. So this is supposed to be the best method for controlling the pest. So powder formulations, they are applied on seeds by tumbling the seed. That means the seeds which are very hard to remove from the fruit. So the powder formulations are applied on seeds by tumbling seed with the product that is designed to adhere or get coated to the seeds. So this is called as seed treatment. So it is the best method. That is one way to apply the biopesticides is the best method or the technique where the powder formulations are applied on seeds by tumbling seed, removing the seed from the fruit with the product that is biopesticide that is designed to adhere or get coated to the seed. And next we have foliar applications. Number one is seed treatment. Number two is foliar application. So we are essentially trying to understand the different techniques or methods used for application of the biopesticide. So under that, second method is foliar application. This means biopesticides applications on leaf surfaces in the form of sprays. Right, you are essentially spraying on the leaf surfaces. So, for example, application of Bacillus subtilis to bean leaves. It has reduced the incidence of bean rust caused by Euromyces fascioli. So, there is a report which mentions about reduced infection of the bean leaves by bean rust caused by Euromyces fascioli by using the foliar applications. That means the biopesticides are applied on leaf surfaces in the form of sprays. And next we have seedling dipping. The third method is seedling dipping. This involves dipping roots of the seedlings, right? roots of the seedlings in biopesticide suspension. Now the biopesticide is in the form of suspension for few minutes or even for few hours prior to transplanting. Right. These are all simple techniques to understand and to know, but it requires a lot of skill to carry out the method. So, seedling dipping, this is the third important technique. This involves dipping roots of the seedlings in biopesticide suspension for few minutes or for few hours prior to transplanting. So, the time required for dipping the roots of the seedlings is dependent upon the type of the roots which has been selected, that means the crop which has been selected, and also the biopesticide that is specifically used. So it could be, or it ranges from few minutes to few hours, that is dipping roots of the seedlings in the biopesticide suspension prior to or before transplanting, right? So as an example, we have the trichoderma species which are used in this way. So these are some of the important methods or techniques used for efficient control of the pest. Next, we'll try to understand the mechanism of action of biopesticide for pest control. There are essentially four different mechanisms by which the biopesticide controls the pest. Number one, antibiosis. Number two, competition. Number three, hyperparasitism. Number four, synergism. Right? So these are the four important mechanisms by which the biopesticide intend to control the pest attack. Number one, antibiosis. Number two, competition. Number three, hyperparasitism. Number four, synergism. So what is antibiosis? Antibiosis, this occurs as a result of an interaction with other microorganisms, and it is mediated by specific metabolite of microbial origin, right? Say for example, volatile compounds, lytic enzymes, or other toxic substances. So antibiosis essentially occurs as a result of an interaction with other microorganisms mediated by specific metabolite of microbial origin by volatile compounds, lytic enzymes, or other toxic substances. So the microorganism produce antibiotics, bacteriocin, volatile compound, and metabolite production. So this is about antibiosis, by which this is one of the important mechanism by which the biopesticide controls the pest attack. Next we have competition. So it is another mechanism of control by biopesticides. So it is their ability to compete aggressively, that they grow rapidly and colonize substrate to exclude the pathogens. Right. So this is an important mechanism. Next to antibiosis, another mechanism of control by biopesticide, it is their ability to compete aggressively, that they grow rapidly and colonize substrate to exclude the pathogens. Say for example, we have the trichoderma species, which are aggressive competitors of fusarium species. So they over grow against the fusarium species. So that shows the aggressive competition between the two organisms. So it is called as competition mechanism of action of biopesticides to control against the pest. Right. Next we have hyperparasitism. So it is the lysis of the death, or it is the lysis of the death by other microorganisms, or direct parasitism. Say for example, we have the Trichoderma lignorum. It is found to be parasitizing the hyphae of Rhizoctoni solani, and therefore soil inoculation with Trichoderma spores help to control damping of disease in citrus seedlings. So this damping of disease caused by the Rhizoctonia solani. So that is controlled by the Trichoderma lignorum. So it is the lysis of the lysis or the death by other microorganisms or direct parasitism. So this is called as hyperparasitism. So this is another important mechanism by which the biopesticide control the pest attack. And last we have the synergism. So it is the ability of some of the bioagent to combine actions of hydrolytic enzymes and antibiotic secondary metabolites. Right. So the ability, this is under synergism. So in a synergism in the sense, synergistic in the sense working together. Right. So the ability of some bioagent to combine the actions of hydrolytic enzymes and the antibiotic secondary metabolites. So it's a combination of two different molecules or compounds. Say for example, the effectiveness of Trichoderma species as a biocontrol agent and its fitness in the environment is a result of synergistic effect of antimicrobial compounds. So that includes pyrrones and coumarins, etc. So this is called as synergism, and it is an important mechanism by a mechanism of action of biopesticides for pest control. So there are four important mechanisms as we have discussed. Number one, antibiosis. Number two, competition. Number three, hyperparasitism. Number four, synergism. Right? And what are the advantages? So these are the general advantages I have listed over here. Number one, biopesticides are usually inherently less harmful or toxic, and they cause less environmental load or pollutions in comparison to the synthetic pesticides. Right. So they biopesticides, they are inherently less harmful or toxic, and they cause less environmental load or pollutions. So this is in comparison with the synthetic pesticide. And number two, designed to only one specific pest, or in some cases a few target pests, it could be there, as opposed to chemical pesticide that have a broad spectrum activity. So the synthetic pesticide or the chemical pesticide is having a broader specificity or activity, but biopesticide is not like that. Biopesticide is target specific or designed for a specific target so that it doesn't harm other organisms of the habitat. So this is the important advantage. It is designed to only one specific pest, or in some cases a few target pests, as opposed to the chemical that have a broad spectrum activity. And number three, the cost of developing biopesticide is significantly less than those of synthetic chemical pesticide. So even it is cost effective in terms of the manufacturing of biopesticide in comparison to the synthetic pesticide. And number four, their nature of control is preventive, not curative. So this is important. So the biopesticide, essentially what we have seen is prevention. So four mechanisms we have seen. The four mechanism doesn't involve the curative process. It is only preventive process. And their effects on flower is less, so that the seeds are not harmed, right? And it is not toxic or lethal to the seed. So number one, biopesticides are less harmful, and they cause less environmental load or pollution, and they are designed to only one specific pest, and in some cases few target pests. And the cost is and it is cost effective. Cost is less compared to the synthetic pesticide, and their nature of control is preventive, not curative. Then, if you try to understand about disadvantages, number one, specificity is high, which may require an exact identification of the target pest. If it is not identified, then the specificity is lost. Because of their slow speed of action, biopesticides they are often unsuitable if a pest outbreak is immediate. So this action is slow. So if there is an outbreak, immediate outbreak, then this becomes a failure. Then biopesticides are not suited for a standalone treatment. Rather, they have to have a compatible method with high efficacy. And number four, living organisms evolve and increase their resistance to biological, chemical, physical, and any other form of control. So I have listed the general disadvantages. That is number one, specificity is high. So that means it requires an exact identification of the target pest or pathogens, and that is a challenge. And number two, because they are slow or the speed is slow in action. So if there is an immediate outbreak, then it becomes a failure. And biopesticides are not suited for a standalone treatment. It requires a compatible method for higher efficacy. And living organisms, they evolve. We know that they evolve and increase, or their resistance is increased to either biological, chemical, or physical, or any other form of control. So these are about the disadvantages, which are very, very general compared to the chemical pesticides. So I have discussed in detail about the concepts of biopesticides, what the biopesticides are, what are the formulations of biopesticide, what is the mechanism by which the biopesticide act, and also we have discussed about the general advantages and disadvantages of the biopesticides. So I'll stop my discussion over here. In the next session, we can continue our discussion with another concept that is the bio leaching. Thank you very much for your kind listening. Thank you.